In this problem, we're going to sum sine squared from 1 to 90 degrees. Then we're going to subtract the sum of cosine squared, also from 1 to 90 degrees. Amazingly, this intimidating sum can be calculated in just seconds. Pause the video and see if you can calculate this sum without using a calculator, of course. After I show you the solution, I guarantee that you will want to try this out on your friends or even your teachers. So what's the first step? We need to combine the two sums into one. Next, we can multiply the outside of the sum by -1 and switch the signs of sine squared and cosine squared. That doesn't change the sum's value, but it does allow us to immediately recognize a trig identity that we can use, namely the cosine double angle formula, which states that cosine 2x equals cosine squared x minus sine squared x. Let's therefore get rid of the cosine squared minus sine squared and replace it with cosine 2n. So now let's see what this sum looks like when we expand. We get the negative of cosine 2 plus cosine 4 plus cosine 6, and so on, all the way up to cosine 180. It looks worse than before. How on earth are we going to simplify this mess? By taking a closer look at the cosine function. Now, normally we think of cosine x as a classic even function, which it is. That means cosine x equals cosine negative x, which we can easily confirm visually. Notice that cosine of 20, for example, is at the same y value when we evaluate cosine minus 20. But something interesting happens if we look at the graph on the interval from 0 to 180, which I drew in blue. On this interval, cosine x actually becomes an odd function with respect to 90 degrees. That means cosine x equals the negative of cosine 180 minus x. So cosine 20, for example, is the negative of cosine 160. That means those two values cancel out in our sum, and that means every single term in our expression above will cancel out except the cosine 180 term, which still has a negative in front of it. And since cosine 180 is -1, we're left with the negative of -1, which of course is 1. So we can conclude that the original expression simply evaluates to 1. Pretty amazing. Let me know in the comments below if you got the answer and if you got it using a different approach. And be sure to subscribe for a new video every week featuring puzzles, problems, applications, and explorations. Thanks for watching and see you soon.